You know, when you think about it, so much of the world's knowledge, we're talking financial reports, scientific breakthroughs, you name it, is trapped inside documents like PDFs. It's just sitting there. Well, today, we're going to learn how to pick that lock.
Okay, let's get right into it. Take a look at this page from a scientific paper. Now, to you and me, that table looks simple, right? It's organized, it's full of data, totally clear. But to a computer, oh, it's a completely different world.
And that's the big puzzle we're tackling. How do we get a machine to see this thing not as just a flat picture with some text sprinkled on it, but as a real structured table with rows and columns it can actually understand and work with?
We actually call this the locked box problem, because to a computer, a PDF isn't a dynamic document. Nope, it's more like a photograph of a page. All that beautiful structure that's so obvious to our eyes, completely invisible to the machine.
And here's why it's so tough. A computer doesn't see columns, it doesn't see rows. It just sees a random list of text snippets, like the word inhibitor or the number 0.0409, and each one has a location, an X and Y coordinate. That's it. It's basically a digital soup of words and numbers with no recipe to follow.
So, how do we solve this? Well, what if we could give the computer eyes? And that's exactly where modern AI comes in. We can use these incredible computer vision models to let the machine see and understand the layout of a document, just like a person would.
The game plan is actually pretty straightforward, just 3 steps. First, we unleash a powerful vision model, in this case, one called YOLO, which is fantastic at spotting objects, to scan the page. Second, we give it a very specific mission. Go find the tables. And finally, once the AI draws a little virtual box around that table, we can grab just that piece and get to work.
Now this is where it gets really cool, because this is how we actually tell the AI what to do. It's not magic, it's just a few instructions. We set the strategy to high res, so it looks really closely. We tell it which model to use, YOLO X, and here's the secret sauce. We set PDF infer table structure to true. That's us literally telling the AI, hey, pay attention, I'm pretty sure there's a table here, and I need you to figure out its structure.
All right, our instructions are in. The AI goes to work. And this brings us to the moment of truth, the big reveal. This is where we see if we can turn that flat image into something truly useful.
So, what's the first thing you'd try? You found the table, so you just ask the computer to read the text inside it, right? Seems simple enough.
Well, what we get back is this, a giant, messy blob of text. I mean, sure, all the words and numbers are there, but they're just smashed together. There's no structure, no context. This is pretty much useless for any kind of real analysis.
Okay, so that was a bust. But don't worry, there's a much better way. Turns out the AI was doing more work behind the scenes than it let on. The real treasure isn't in that main text. It's hidden away in the metadata.
And this is the golden ticket right here. It's a property called text_as_HTML. While the AI was figuring out the layout, it was also quietly building a perfect, structured HTML version of the table. It already did all the heavy lifting for us. We just needed to know where to look. So now that we've found this hidden gem, let's put it to use. We're about to see how this one little property gives us the exact perfect structure we wanted all along. And boom, there it is. Just by grabbing that text_as_HTML property, we get this beautiful structured table. We've got clean columns for every piece of data, it's organized, it's machine-readable, and it's ready to go.
And you know, this table you're seeing, it's not just a pretty picture. It's actually being rendered from real, standard HTML code that the AI generated all by itself.
If we peek under the hood, we can see the AI used all the right building blocks. The table tag, head for the table head, t-body for the body. It did everything by the book. It basically translated that static image into a universal language for data.
So we went from a flat image to clean, structured code. That's a really neat trick for sure. But why does it really matter? What can we actually do with this?
Oh, the possibilities are massive. For data analysis, you can now pipe this info straight into your tools. No more soul-crushing manual data entry. For automation, think about processing thousands of invoices or lab reports in seconds. For AI and RAG, this is huge. It gives large language models the clean, factual data they need to give you reliable answers. And maybe most importantly, for accessibility, this turns visual data into something a screen reader can understand, making information available to everyone. And that kind of leaves us with one final thought. We just unlocked the data from this one table. It really makes you wonder, doesn't it?
If we can do this for tables, what other vital information is still locked away in all our documents, just waiting for us to find the right key?